The hot plasmas in jet and in mast don't like to stay still and they often jump up or down. I developed the control system on mast which uses magnetic fields to catch the plasma and bring it back to where we want it to be.
So I'm a physicist working in the neutral beam heating group. We operate one of the heating systems that's used on jet to heat the plasma to temperatures of over 150 million degrees centigrade.
I am a physicist in the tritium group at CCFE. So we provide jet with the tritium fuel that it needs for fusion experiments, and my job involves a nice mixture of computer programming and designing experiments.
I'm a materials scientist and I work with a team of other scientists and engineers, and we create and assess different materials for future nuclear fusion reactors.
I am a graduate process engineer, and that means that I rotate around lots of different departments here at CCFE, and currently I'm in the vacuum group and it's my job to relocate a couple of pumps.
So I'm a mechanical engineer and I work across site on different reactors, and most of the time I'm working on designing and improving different reactor components.
I love being part of cutting-edge research, and I love being able to directly apply the physics that I learnt at school and university in a real-world context.
I love the variety of projects and the broad range of skills that I get to learn and use. I love the look on people's faces when I tell them that I make stars, but most of all, I love that I learn something new every day.
I love the creative and problem-solving aspect about my job, and also in science, the discovery of something new, no matter how small it may be, is incredibly satisfying. I studied maths, physics, chemistry and music technology at sixth form. I then undertook a 3-month internship at a nuclear facility in Australia, and then after uni I was accepted onto CCFE's grad scheme.
I did physics, maths and German for A-level, and then I studied physics at university. And my physics degree included a year spent in Germany as an exchange student, which was a brilliant experience.
I chose maths, physics and biology at A-level, and then I worked in industry for a year. I studied a master's degree in cybernetics, which is similar to robotics, and then I decided to stay on and do a PhD.
So at A-level I studied maths, physics and economics, and then at uni I studied physics, where I worked summers in an engineering consultancy and then a placement year as an engineer. After graduation I ran a microscopy lab and now I work here.
So at A-level I took maths, physics and geography, and then I went to university and I did a master's in mechanical engineering. I also did an internship on my summer holidays, and I really think that was helpful because I got really good industrial experience.
So I studied physics at high school and university, and then while I was at university I did an internship at Fermilab in Chicago. That gave me a really great experience at working in a big lab doing big science, and also the pizza was great.
So currently I'm really into rock climbing right now, and I'm spending lots of weekends away climbing on the Jurassic Coast in Dorset.
So I love running, cycling and slacklining, and then indoors I also like playing the piano and the guitar.
I trampoline and I'm a trampoline coach. I also love to craft, and these days I do a lot of DIY.
When I'm not at work I really like getting out on my bike as much as I can, also like heading to the climbing wall, and also like playing my guitar as well.
Outside of work I like to consider myself a bit of an amateur chef, with the emphasis on the amateur. I really enjoy trying new recipes, and Italian in particular is my favourite at the moment.
I like playing board games, going to the theatre and visiting new places.
As a world expert in the control of fusion plasmas.
So in the future I'd really like to still be working in fusion research. The next fusion reactor is ITER, which is being built in the south of France at the moment, and I can really see myself living near the Med.
Fusion is important because fossil fuels are running out and we need an alternative sustainable source of energy. The raw materials that we require for fusion, that is deuterium and lithium, are abundant and easily available.
So fusion is important because it provides a safe alternative to nuclear fission. When we think of fission, we think of runaway chain reactions, we think of nuclear fallout. All of these safety concerns aren't an issue with nuclear fusion.
Fusion is important because of the vast amount of energy that it releases from only a small amount of fuel. So for example, you would need to burn 400,000 tonnes of coal to get the same amount of energy that you could get from only 60 kilograms of fusion fuel.
Fusion is important from a waste perspective because fission reactors produce waste which stays radioactive for thousands of years. Fusion also does produce waste, but it stays radioactive for only hundreds of years, making it much more manageable and easier to store.
Fusion is really important because it's a clean energy source. So this means that absolutely no CO2 is given off to the atmosphere.
Fusion is going to totally change the world and how we live our lives. So imagine a world with a constant supply of high-yielding energy 24 hours a day, 7 days a week, 365 days a year.